Yeah, so today I'll be presenting on the Facies analysis, modelling and geological mapping of the Wagga Southern Nights deposit in the southern Cobar Basin. So I think I'll skip past this one because we've probably seen it all before. So firstly, I'd like to acknowledge previous work that was done by Bob Brown, Nancy Vickery, Gerard Tripp, Rob Tyson and Angus Hornibrook, and also like to acknowledge Rachel for her help in producing the diagrams and maps that you'll see in this presentation, and to all of our colleagues at Peel, in particular Cam, Millie, Jason and Victoria, and a special thanks to Carol Simpson for her input on volcanology, and to Mick Oates for no other reason than keeping the coffee machine running. So the first aim of the study was to categorise each lithology that we see in drill core into distinct facies. We then used the characteristics of these facies to identify a modest volcanic centre and multiple synvolcanic faults within the deposit. We then produced a two-dimensional model of the facies architecture that delineates the location of the volcanic centre and synvolcanic faults and highlights their spatial relationship with stockwork zone and massive sulphide mineralisation. We then used geological mapping in conjunction with the facies model to delineate prospective stratigraphy outside of the current resource. And lastly, we used geophysics, in particular IP, to generate targets for further testing, especially where they were coincident with prospective stratigraphy. So the Wagga Southern Nights deposit is located 150 kilometres south of Cobar on the western edge of the Mount Hope Trough. It's a polymetallic zinc, lead, silver, copper, gold deposit whose textures and geochemistry strongly suggests a VMS affinity. The mineralisation is steeply west-northwest to northwest dipping, and it's locally overturned to the southeast of Wagga Tank, and it's hosted within a package of volcanic and sedimentary rocks of the Mount Kinnon volcanics. The deposit is of a low strain environment and has a lower green schist facies metamorphic grade. So the stratigraphy comprises a package of largely volcanic-derived subaqueous mass flow deposits and local coherent rhyolites that together are collectively and formally termed the Vivigani Formation. And these volcanic rocks are contained within deep water, rhythmically bedded turbidite facies, shales, siltstones and sandstones that are informally termed the underlying Eastern Formation and overlying Wagga Tank Formation. Together, these rocks are unconformably overlain by transported cover deposited during the Tertiary and the Quaternary period, and that ranges in thickness from over 100 metres to areas of outcrop. The mineralisation comprises stratiform laminated to banded to massive sphalerite, pyrite, galena, chalcopyrite, and this is discordantly underlain by intensely altered stockworks of disseminated and veined sulphides. So the mineralisation has been defined discontinuously over a total strike length of 2 kilometres at 4 principal locations. Wagga Tank in the north, the Link Zone, Southern Nights Central and Southern Nights South. And thanks to the GNSSW for the seamless geology on the map there. Only a modest amount of mineralisation is contained within Wagga Tank and the Link Zone, and the vast majority of the resource is hosted within Southern Nights Central and Southern Nights South. So as of March 2020, the total resource is 4.95 million tonnes at 5% zinc, 2% lead, 0.3% copper, 78 grams per tonne silver, and 0.4 grams per tonne gold. So the first facies that we describe is the Eastern Formation turbidite facies, and this is typically a deep marine turbidite that comprises massive to thinly bedded shales, siltstones, and sandstones. Graded bedding is common, and locally this facies hosts polymetallic stringer veining at Wagga Tank. The Vivigani Formation coherent rhyolite facies is an apheric to locally sparsely plagioclaspheric rhyolitic lava that hosts abundant quartz-filled amygdales that are often flattened and aligned into a primary flow-banded fabric. These amygdales are hosted in a devitrified, originally glassy ground mass, which is evidenced by spherulitic and micropoikilytic textures like we can see in the thin section image here. The margins are commonly brecciated, which is evidenced by crackle to jigsaw fit textures, and we believe these form from the in situ quench fragmentation of the lava as it flowed into a marine environment. Now, this facies forms a dome-like structure on the paleo seafloor. It's approximately 2 kilometres in length, and currently we do not know the thickness of this unit. However, we do know it's a minimum of 250 metres thick. So stratigraphically above and laterally adjacent to the coherent rhyolite is the Vivigani Formation rhyolite-bearing mass flow breccia facies, and this comprises subangular to sub-rounded class of shale siltstone, sandstone, and lesser coherent rhyolite in a shale matrix. Fabrics are usually chaotic, and they range from matrix supported, like in the top run here, to class supported, like you see in the bottom run. Now we believe these form from subaqueous mass flows during the gravity-driven collapse of unstable autoclastic breccias at the coherent rhyolite margins, and this is analogous to similar facies that you see at the Highway Reward deposit in Queensland. Less commonly, we see this facies as smooth, very well-rounded class of coherent rhyolite that are hosted in a sandy matrix, and fabrics are class-supported, and we interpret these as resedimented lava clasts that were spooled from steep-sided flow fronts of coherent rhyolite bodies through curvy planar fracturing, like you can see in the bottom run there. So the Vivigani Formation volcaniclastic facies is comprised of a volcaniclastic sandstone and breccia, and the sandstone is composed of subangular to sub-rounded felsic lava grains, sedimentary grains, and volcanic quartz, and the fabrics vary from massive to thin-bedded, with local cross-bedding and graded beds, like you can see in the top image. The volcaniclastic breccia is typically polymicted, with class of sedimentary and volcanic provenance, and again, fabrics are chaotic, and they range from class-supported, like in the bottom run, to matrix-supported. And together, we believe that the volcaniclastic sandstone and breccia represent coarse debris flow deposits. The deposition would have been episodic, with quiescent periods marked by the deposition of fine-grained pyrite, like you can see in the top run. And certain features within the facies, such as well-preserved crinoids, corals, and limestones, may indicate proximity to emergent or near-emergent volcanic centres and/or synvolcanic faults. Or alternatively, features such as subtle cross-bedding in the volcaniclastic sandstone facies may indicate a more quiescent environment that's distal from volcanic centres and synvolcanic faults. So the Vivigani Formation porphyritic intrusive rhyolite facies only occurs locally at the link zone and is a crystal-rich quartz feldspar ferric rhyolite that contains minor phenocrysts of biotite. It's commonly in pepperitic contact with intensely carbonate-altered sediments, and we believe this represents a very high-level synvolcanic intrusion, either a dike or a sill, that was emplaced into wet, unconsolidated sediments. And lastly, the Wagga Formation turbidite facies is again another deep marine turbidite facies that's very similar to the Eastern Formation. However, the absence of abundant fine-grained sandstone may suggest a more distal environment than existed in the Eastern Formation time. They're typically thin-bedded shales with subordinate siltstone, with common graded bedding, sharp bases, scours, and occasional cross-bedding. Now, we often see common euhedral and recrystallised pyrite that's proximal to the Vivigani Formation contact. And it's this facies that host the stratiform massive sulfides, and they comprise finely laminated to banded massive sphalerite pyrite galena chalcopyrite, and they're hosted at the base of this facies at the contact with the Vivigani Formation. So we were able to use facies analysis to identify the presence of a modest volcanic centre and multiple synvolcanic faults within the deposit that we believe are spatially associated with stockwork zone and massive sulfide mineralisation. In order to identify the synvolcanic faults, we look for certain features within the facies that were useful in the detection of the synvolcanic faults, and they include felsic lava flows, domes, and cryptodomes marking volcanic centres, synvolcanic dikes and dike swarms, hydrothermal alteration that preferentially develops within those dikes, diachronous wedges of talus, talus blocks, and debris flows, and the growth of footwall sequences over a short lateral distance. So 1, felsic lava flows, domes, and cryptodomes marking volcanic centres. So we see evidence for this at the link zone, where there are commonly thick intersections of the coherent rhyolite facies, whose margins are commonly brecciated, and together we interpret this as a felsic lava flow or dome that quenched and fragmented as it was extruded onto the seafloor. Synvolcanic dikes and dike swarms, well again we see evidence for this at the link zone in the form of the porphyritic intrusive rhyolite facies that's commonly in pepperitic contact with intensely carbonate-altered sediments. And it's the differing contact relationships and textures between the coherent and porphyritic intrusive rhyolite facies that may indicate that there were multiple generations of lava domes, sills, and dikes forming at the volcanic centre here. So furthermore, the synvolcanic dikes are commonly intensely sericitised, with almost the entire ground mass replaced by fine-grained sericite, as we can see in the two images here. And we interpret that as hydrothermal alteration that preferentially developed within the dikes that occupy the synvolcanic structure here. So again, at the link zone, we see diachronous wedges of talus, talus blocks, and debris flows, such as this amazing example of a densely packed breccia that's comprised of a class of coherent rhyolite and disarticulated crinoid and coral fragments. And these rocks are present around the margins of the lava dome, which may indicate that it emerged to relatively shallow water depths, and rapid disruption during volcanic eruptions and or synvolcanic fault failure could have triggered their collapse. And lastly, the growth of footwall sequences over a short lateral distance. Well, we see evidence for this in drill core, where there is a distinct thickening of the volcaniclastic facies, and we also see it preserved in outcrop in an area between Wagga Tank and the link zone. And this image here is taken from the geological map that will be discussed in more detail further in this presentation. And so we were able to use facies analysis to identify a modest volcanic centre and multiple synvolcanic faults that we believe are spatially associated with the stockwork zone and massive sulfide mineralisation. And so taking into account all that evidence and also mapping the individual facies from drill core data, we were able to produce this scaled two-dimensional model of the facies architecture. So we can see that the coherent rhyolite facies and the porphyritic intrusive rhyolite facies marks a lava dome at the link zone, which marks the volcanic centre there that's spatially associated with the stockwork zone and massive sulfide mineralisation. A distinct thickening of the volcaniclastic facies in drill core and also preserved in outcrop, as I previously mentioned, has been used to infer the presence of a synvolcanic growth fault at Wagga Tank and also at Southern Nights Central. And lastly, the presence of stockwork zone mineralisation and massive sulfide mineralisation, in addition to a felsic lava flow or dome, has been used to infer the presence of a synvolcanic growth fault at Chukchi's Lode in Southern Nights South. And so, as I mentioned previously, there's question marks along the basal contact of the lava dome, and that's because to date, drilling has failed to intercept the whole entire body of coherent rhyolite there. And it's very difficult to observe these synvolcanic faults directly, and so their dip and orientation has been inferred from all the available data and also the synvolcanic fault that was mapped in outcrop. And so there's a big question that remains amongst our geos, and that is, where does the rhyolite that forms the volcanic centre come from? So one current hypothesis that we have is that we have a subvolcanic intrusion beneath the deposit that is driving the convection of hydrothermal fluids, and that may be represented by this large circular feature that's on the magnetics. And it's possible that the rhyolite that forms the lava dome or the volcanic centre has ascended from this subvolcanic intrusion through the exploitation of those deep penetrating synvolcanic faults. And so we're currently of the belief that the textures and geochemistry of the mineralisation and hydrothermal alteration strongly suggest that Wagga Tank Southern Nights is a volcanic associated massive sulfide deposit. And I'll discuss these textures and geochemistry in more detail in this section of the presentation, whilst making reference to the VMS model. And so the highest grade sulfides occur as finely laminated to banded to massive sphalerite, pyrite, galena, chalcopyrite, and the laminations are often parallel to the bedding in the enclosing shales, like you can see in the top image there. They have a distinct lead, silver, cadmium, antimony, zinc geochemical signature that is consistent with the VMS model, and we believe that with cessation of the Vivigani volcanic event, venting fluids were no longer being diluted by large volumes of volcaniclastic sediments, and so economic accumulations of sulfides were able to develop undisturbed on the seafloor. Stratiform quartz, pyrite, hematite, exolite horizons are present locally, and they form marginal aprons at the same stratigraphic horizon of the massive sulfides. And we believe that these represent the precipitation of amorphous silica and iron during the final stages of sulfide mountain development. And so discordantly underlying the massive sulfides and the exolite horizons is the sulfide stockwork zone, and that comprises disseminated and vein-hosted sulfides that observe a vertical zonation from pyrite chalcopyrite at depth, transitioning up sequence to veins that are dominated by sphalerite, pyrite, and galena. And it's the pyrite chalcopyrite veins that have a distinctive copper gold bismuth indium molybdenum signature that is again consistent with the VMS model. So spatially associated with the most intense parts of the sulfide stockwork zone is the iron-rich chlorite zone, and that forms the core of a laterally zoned alteration halo that is present beneath the massive sulfides. And it's this iron-rich chlorite core that grades outwards to a zone that's dominated by magnesium-rich chlorite. And this magnesium-rich chlorite zone grades outwards again to a zone that is dominated by cerussite and to a lesser extent silica-cerussite. And magnesium metasomatism and sodium depletion within this zoned alteration halo is again consistent with the VMS model. And so recognition of Wagga Tank Southern Nights as a probable VMS deposit and the generation of the new Facies model triggered a review of our previous geological mapping to see if we could identify any prospective stratigraphy outside of the current resource. And so the original mapping that we had at the time was of very high quality, but it had not placed the outcrops into stratigraphic context. And so what we did was use our new Facies model to categorize the outcrops into their distinct facies in order to produce a more simplified outcrop and inferred geological map. And that was the result. And so you can see the Wagga Tank Southern Nights deposit on the left-hand side of the image there, and that has the mapped syn volcanic growth fault between Wagga Tank and the link zone that I discussed earlier in this presentation. And of particular interest to us was the contact between the Wagga Tank Formation turbidite facies, which is the dark grey unit, and the Vivigani Formation volcaniclastic facies, which is the pale blue unit. And as you can see from the strat column on the right-hand side of the slide, it's that contact that hosts the high-grade stratiform massive sulfides. And so we were able to trace the contact with confidence around the nose of an anticline, known as the Wagga Tank anticline, and southwards around a syncline, known as the Pine Valley syncline, and up towards the Bird and Fence Line prospects for a total of over 3.5 kilometres. And almost the entirety of this contact still remains completely untested. Also of significance is multiple outcrops of coherent rhyolite facies, and these may indicate additional volcanic centres that have the potential to host stockwork zone and massive sulfide mineralisation, like they do at the Wagga Tank Southern Nights deposit. And this here is a cross-section from Wagga Tank Southern Nights on the left over to the fence line on the right, and that just gives you a general idea of what the structure of the subsurface is between the two areas. And these are some typical outcrops that you can expect to see from the mapping area. We have the Wagga Tank Formation shales in the top right, Vivigani Formation volcaniclastic breccias in the bottom right, and less commonly we see examples of float and subcrop of strongly gossinous volcaniclastic breccias and shales, and this is from the contact between the Wagga Tank Formation and Vivigani Formation to the east of the deposit, and these XRF readings indicate that these rocks are highly anomalous. And so recognition of the prospective stratigraphy to the east of the deposit led us to conduct a dipole-dipole IP survey of the entire mapped area. Unsurprisingly, this survey produced significant chargeable anomalies at areas of known mineralisation, such as Southern Nights South, Central, Link Zone, and Wagga Tank. However, the chargeable anomaly at the link zone is significantly larger than any of the others and is coincident with the now mapped syn volcanic growth fault and the now known volcanic centre there. And this just highlights that area for more further testing. Also of significance are chargeable anomalies to the south of Southern Nights, to the north of Wagga Tank, over at the Bird and the Fence Line prospects. And there's a fixed loop EM, chargeable AEM, and chargeable IP anomaly proximal to the nose of the Wagga Tank anticline. And I'm not sure if you can see it, but there are minor chargeable anomalies within the volcaniclastic facies at the Pine Valley syncline hinge zone. And lastly, this image shows our historic drilling at the fence-lined prospects that returned significant results, such as 13 metres at 21.5% lead, 120 grams per tonne silver, and 4.36 grams per tonne gold. And what the geological map shows with this image is that all of the drilling was likely done in the stockwork vein zone that's within the volcaniclastic facies and the Eastern Formation turbidite facies, and the higher grade Wagga Tank Formation Vivigani Formation contact, which is the contact between the dark grey unit and the light blue unit, remains completely untested to the west. And if you remember, it's this contact that hosts the stratiform massive sulfides. And so future drilling in this area will be directed along this contact, particularly where it's proximal to that outcropping coherent rhyolite facies, which again may indicate the presence of another volcanic centre or synvolcanic fault. And so to conclude, we use facies analysis to identify the link zone volcanic centre and multiple synvolcanic faults. We then produced a 2D Facies model of the deposit that highlights their control on mineralisation. We then used geological mapping in conjunction with the model to delineate over 3.5 kilometres of prospective stratigraphy outside of the current resource. We then further refined the targets with the dipole-dipole IP survey. And lastly, we used geological mapping and the Facies model to show drilling at the fence line was likely in the footwall stockwork zone, and the higher grade Wagga Tank Vivigani formation contact remains untested. Thanks for listening.